Suppose that the position of one particle at time t is given by x subscript 1, which is equal to 3 times the sine of t, y subscript 1 equals 2 times the cosine of t, where t is in between 0 and 2 pi. And the position of a second particle is given by x subscript 2, which is equal to negative 3 plus the cosine of t, y subscript 2 is equal to 1 plus the sine of t, where t is in between 0 and 2 pi inclusive. We want to graph the paths of both particles. How many points of intersections are there? So what we can do is we can go ahead and graph this on Desmos. So let's go ahead and do that. We're going to first put in our ordered parametric equation. So we have 3 times the sine of t, comma, 2 times the cosine of t. Okay, and then we're going from 0 to 2, and then just type in the word pi for pi. Okay, and then our second equation, our second parametric equations, are given by negative 3 plus the cosine of t, and then 1 plus the sine of t. Okay, and then we got to put in our interval, so it's going from 0 to, again, 2, and then write the word pi. So if we take a look at this, okay, let's go ahead and copy. Okay, so we can see that there's how many points of intersection? Well, there's one here and there's one there, so there's 2 points of intersection. Now, are any of these points of intersection collision points? In other words, are the particles ever at the same place at the same time? And if so, find the collision points. Now, a collision point occurs when x1 is equal to x2 and when y1 is equal to y2 for the same value of t. So what we want to do is we want to be able to solve equations. So let's take a look at the equations that we have from above. So our first equation is we're going to let x1 equal x2. So that's 3 sine of t, which is equal to negative 3 plus the cosine of t. Then our second equation is going to be 2 times the cosine of t, which is equal to 1 plus the sine of t. And so from equation 2, we have 1 plus the sine of t, which is equal to 2 times the cosine of t. And if we solve for the sine of t is going to equal 2 times the cosine of t minus 1. And now we're going to substitute that into equation number 1. So we have 3 times the sine of t, which is 2 times the cosine of t minus 1. And that's equal to negative 3 plus the cosine of t. So if we distribute the 3, we get 6 times the cosine of t minus 3, which is equal to negative 3 plus the cosine of t. So if we subtract the cosine of t to the left side, we end up with 5 times the cosine of t. And if we add 3 to both sides, we get 0. And so therefore we have the cosine of t, if we divide both sides by 5, is equal to 0. The question is, what values of t is going to equal 0 when you take the cosine? Well, we know that t is going to have two solutions. One of them is pi over 2, and the other one is 3 pi over 2. So now let's check for pi over 2. So if we check for when t is equal to pi over 2, for equation 1, we should have 3 times the sine of pi over 2, and that's equal to negative 3 plus the cosine of pi over 2. So the sine of pi over 2 is 1, so 3 times 1 is 3. And then over here we have negative 3 plus the cosine of pi over 2. The cosine of pi over 2 is 0. So therefore, it does not work for pi over 2. So we don't need to check the second equation. Now, if we check when it's equal to t is equal to 3 pi over 2. So the first one, we have 3 times the sine of 3 pi over 2. And does that equal negative 3 plus the cosine of 3 pi over 2? We know that the sine of 3 pi over 2 is negative 1 times 3 is negative 3. We know the cosine of 3 pi over 2 is 0. So therefore we have negative 3, so it checks for that one. And then let's try the second equation. So we have 2 times the cosine of 3 pi over 2. We want to see if that equals 1 plus the sine of 3 pi over 2. So this is 2 times 0, which is 0. Over here, this becomes 1 plus negative 1, which is also 0. So that checks. And so therefore, in summary, we can see that, so the only collision point occurs when t is equal to 3 pi over 2. And this gives us the point negative 3, 0. And if we take a look up here, negative 3, 0 is the only collision point. So now let's check and look at C. It says, describe what happens if the path of the second particle is given by the following. So here we have new equations. So let's go ahead and go into Desmos. And so the second one now is going to change to plus 3. So it's 3 plus the cosine of t, and then 1 plus the sine of t. So when we look here, we should see that it intersects at 2 points so far from what the graph is telling us. And then we got to use these equations. So here are our equations, and we're going to do the same thing we did in the previous step. And so we can see that there are 2 intersecting points. And if we do the same substitution like we did earlier, we have x1, which is equal to x2, so we have 3 sine of t, which is equal to 3 plus the cosine of t. And our second equation is 2 cosine of t, which is equal to 1 plus the sine of t. And again, if we want to solve for the sine of t in equation 2, we're going to do the same thing. 1 plus the sine of t, which is equal to 2 cosine of t. And we know that the sine of t is equal to 2 times the cosine of t minus 1. And then we're going to plug that into equation number 1. So we have 3 times 2 times the cosine of t minus 1, which is equal to 3 plus the cosine of t. So we end up getting 6 times the cosine of t minus 3, which is equal to 3 plus the cosine of t. If we subtract cosine of t on this side, we get 5 times the cosine of t. And if we add 3 to both sides, we get 6. And therefore, we get cosine of t, which is equal to 6/5. So remember that the cosine of t must be less than or equal to 1. And therefore, this is greater than 1, which tells us that immediately that there are no collision points. But we do still have 2 points of intersection.